designers can achieve big reductions in the embodied carbon in buildings. Amy Hattan, Thornton Tomasetti's Corporate Responsibility Officer, is talking with in-house experts about how they're reducing the effect of buildings on climate change. Here's how Embodied-Carbon is a production of Thornton Tomasetti.
Hi, and welcome to episode 11 of Here's How Embodied-Carbon. This series explores how engineers and designers can fight climate change by reducing the embodied carbon, or the emissions associated with building materials, in the structures they design. I'm Amy Hattan. At Thornton Tomasetti, a multidisciplinary engineering and consulting firm, we've been focused on embodied carbon for over a decade, and we're channeling all of our capabilities to tackle climate change. I'm talking with colleagues about how they're achieving reductions in greenhouse gas emissions on their projects. Today, I'm talking with Elizabeth Brownell, a structural engineer in our Portland, Maine office who works on transportation projects. Liz co-leads the Transportation Working Group within our Embodied Carbon community of practice, and she is a pioneer in exploring how engineers can reduce embodied carbon in bridges. Hi, Liz.
Hi, Amy. I'm looking forward to help bridge the knowledge gap that exists around embodied carbon and bridges.
Terrific. I love having a bridge designer on this podcast. In the architecture and engineering sector, we began our exploration of embodied carbon by looking at buildings, but you raised your hand and said, "Excuse me, what about bridges?" What would you like to share with us today about this growing area of focus?
I'd like to talk about why it's important to consider embodied carbon in bridge construction, how we measure embodied carbon for our bridge projects, and the differences we see in bridge projects compared to buildings.
Okay, let's start with why we should consider embodied carbon reduction in bridges, which isn't yet a typical strategy employed in these kind of projects.
Infrastructure growth is a high contributor to carbon emissions in the atmosphere. And so reducing those emissions is an important aspect of what we do, and engineers see the importance of that. We're trying to educate our clients on why it's important and how we can incorporate it into our transportation projects. The transportation sector is lagging behind the building sector, but we're starting to see some changes in policy as well as some funding opportunities to look at carbon emissions.
Can you please tell us about a few of the policies that you've been tracking?
Sure. New York State issued the Buy Clean Concrete policy, which went into effect in June of 2022. The policy is being implemented in 3 phases. So as of this January, environmental product declarations, or EPDs, were requested on all state-funded projects. In January of 2025, it will be required for concrete mix designs to have EPDs submitted with them. And the next phase will be to meet established global warming potential limits.
That's great. Let me just jump in here to say that anyone who isn't familiar with EPDs can find out more in episode 6 of this podcast. Now, please continue, Liz.
Thanks, Amy. New York State also issued Executive Order 22, which is similar to the Buy Clean Concrete policy, but it expands on it to cover not just concrete, but also asphalt, steel, and glass. The goal of Executive Order 22 is to reduce embodied carbon emissions on all New York State projects, whereas the Buy Clean Concrete policy was meant to start measuring emissions and reporting on them.
That sounds like positive progress.
Yes. And in Maine, where I work, in 2019, the governor created the Maine Climate Council. This is a group of scientists, industry leaders, and bipartisan officials that were tasked with developing a plan to decrease greenhouse gas emissions by 45% by the year 2030 and by 80% in the year 2050. In Maine, the transportation sector is responsible for 54% of the state's annual carbon emissions. And as such, there's a heavy focus on the Maine Department of Transportation to reduce their emissions. But their largest strategy for reducing these emissions was vehicle electrification. And on the building side, a lot of the focus went into building operations. And there hasn't been a lot of discussion around embodied carbon.
Well, that's a bummer. Is there any opportunity to move embodied carbon into the discussion?
Yes, the Climate Council started work in 2020, and they developed a 4-year plan. So now that plan will be coming up for review, and they'll have to report on their progress. This is an opportunity to talk more about how embodied carbon could be an effective strategy to help meet the emissions reduction goals in Maine and in other states that are on the same trajectory.
It sounds like policymaking that includes embodied carbon reduction in transportation projects is just getting started, and that we're on the cusp of change in this area, and that change may come fast. Are we prepared with an understanding of how to measure embodied carbon in bridges and then design for lower embodied carbon?
Yes, measuring embodied carbon for bridge projects is quite similar to measuring embodied carbon in a building. We take the material quantity for each element of the bridge, multiply it by the embodied carbon per unit material, and then transfer this into a normalized number for embodied carbon on the project. We use the functional area of the bridge, using the width as measured from curb to curb, and the length from centerline of bearing to centerline of bearing, to get a normalized CO2 per square foot. With that, we can compare different design alternatives. As structural engineers, we can have an early influence on selecting a bridge's structural system and span configuration to set the baseline for its embodied carbon. We can study different alternatives in the geometry to see how the span configuration, girder layout, and deck thickness influence the amount of embodied carbon. From there, we can optimize individual elements to meet embodied carbon reduction goals.
How would you advise engineers who are familiar with embodied carbon reduction in buildings to adapt their thinking specifically to bridge projects?
There are definitely special considerations for bridge projects at different stages of design. In the scoping phase, we know the approximate functional area of the bridge, and we can use industry averages to establish carbon goals, using some contingencies for risk involved with setting higher or lower goals, depending on the client's level of comfort. Moving into concept design, we have an approximate span and width. We know high-level material quantities, and we can refine our previous carbon assessments using those estimates and arrive at averages for carbon emissions for each material. We then get into preliminary design with the preferred alternative selected. Our estimated quantities are more refined, and the construction sequence has been evaluated. We have an idea of how the bridge will be built, so we can begin looking at more specific emissions for locally sourced materials. This is the time to start thinking about cement replacements, recycled content, and emissions associated with means and methods of construction. At the final stage of design, we have detailed quantities. The specifications have been written, and there are models and drawings we can use to refine our carbon reduction calculations based on the materials outlined in the specs, factoring in things like cement replacement, local materials, and delivery distance from the site. Then during construction, we have actual quantities and we know material waste amounts, so we can use supplier or manufacturer supplied EPDs for particular products. We can get transportation distances and calculate emissions related to construction methods based on the specific equipment that the contractor is using on site and the duration for that equipment to be in use.
So it's important to understand what happens at each stage in a bridge project, which differs from the stages we go through for building design, because there are embodied carbon considerations all along the way. How else do bridge projects differ from building projects?
Well, for a building, it's not uncommon for a project to go up on an empty site. With bridges, there's usually an existing structure in place, so we have to consider the emissions related to the removal and waste of that existing structure, because it can have a large impact on the overall project's embodied carbon. Temporary works for bridges, such as trestles and cofferdams, are also big contributors. And excavation and fill are hard to quantify at the beginning of a project, so we have to keep an eye on excavation and fill quantities as the project progresses, so we can gain more information about how they contribute to the whole project's embodied carbon. Another big consideration is rehabilitation versus replacement, versus actually doing nothing at all. There can be quite a bit of embodied carbon just for typical maintenance of a bridge over time, such as patching concrete and asphalt. We have to consider this in life cycle assessments. Creative solutions to substructure strengthening and reinforcement may reduce the overall embodied carbon compared to taking out the substructure and replacing it, because the foundations can be high contributors to the project's embodied carbon. Also, bridges at remote sites require consideration of travel to the site for workers and equipment and material. And remote sites also may require looking at emissions related to detours.
That's interesting. Can you give us an example?
Sure. On one project, we set up an agreement with a nearby town to allow traffic to be detoured onto local roads. This provided a much shorter detour than one using state roads. Because it was a relatively low-volume crossing, the town agreed, and this made for a big reduction in the carbon impact of the detour. So it takes full life cycle evaluation to think of all the different areas of a bridge project that cause impact.
Liz, thanks for this look at how to approach embodied carbon reduction in bridge projects. How can we speed up the adoption of these strategies in bridge projects right now?
It would make a big impact if we could change the Department of Transportation's standard concrete specifications to include some goals for cement replacement and requiring EPDs for each mix, as well as reporting on embodied carbon quantities.
Well, with people like you sharing your knowledge and voicing your opinion, I think we're going to see some very positive changes ahead. And we'll be crossing that bridge when we get there. Thank you for speaking on this episode today. Folks, there's more. Follow Thornton Tomasetti for more episodes of Here's How Embodied Carbon.